Assalamu alaikum, dear students. In today's lecture, the topics under discussion are electric potential energy, potential gradient, and the electron volt. First, I'm going to start electric potential. The points required to explain electric potential are mentioned here. First of all, I'm going to define electric potential in two different ways. Firstly, the amount of work done in moving a unit positive charge from infinity into a point inside electric field. For the explanation of this definition, here I am considering a source charge plus Q. Around this source charge, there is an electric field represented by this dotted circle. By taking another test charge Q naught, I am taking 2 points, point A and point B. Point B lies within the electric field of the source charge, whereas point A lies beyond the electric field. So here, the work done in moving this unit positive test charge from point A to point B inside the electric field is called electric potential. And secondly, electric potential is defined as the electric potential energy U per unit test charge Q naught is known as electric potential. Dear students, here I am telling you electric potential energy and electric potential are two different physical quantities. Although these two physical quantities are interrelated with one another. Symbolically, electric potential is represented by capital V and its formula is V is equals to U over Q naught. By considering this definition, its mathematical form is electric potential energy per unit test charge is called electric potential. By considering this formula, its unit is joule per coulomb. Overall, this joule per coulomb is called volt. So SI unit of electric potential is volt, and this unit volt is assigned to electric potential in the honor of Italian scientist Alessandro Volta. The next point is dimension. Its dimension is L square m t minus 3 a minus 1. How this dimension comes? I derived it here by considering its formula. V is equals to U over Q naught. Dimension of potential energy is this, and dimension of electric charge is this. By simplification, overall we get dimension of electric potential is L square m into t minus 3 into a minus 1. The next point is nature. Electric potential is a scalar and derived quantity. Being scalar, electric potential does not need any direction for its description, and being derived, electric potential does not come in the 7 basic quantities of physics. The next point is electric potential difference. First, I explained electric potential, and now I am going to explain electric potential difference. Electric potential difference between 2 points is the work done in moving a unit positive charge from one point to another point, keeping the charge in electrostatic equilibrium. Mathematically, electric potential difference can be written as delta V is equals to delta U over Q naught. Here, delta V is equals to electric potential at point A minus electric potential at point B. For the derivation of this formula, I am considering here electric field between two oppositely charged parallel plates. Here I am placing a positive test charge between these parallel plates. This test charge itself moves from point A to point B due to electrostatic repulsive force, and this electric force is equals to Fe is equals to Q naught E. But as this charge is positive, so to move this charge from point B to point A, we have to do an external work. So for moving this charge from point B to A, we used an external force for the movement of this charge from point B to A, and this external applied force is equals to minus Q naught E, because external applied force and electrostatic force both are equal in magnitude but opposite in direction. So here I mentioned as WBA, be the work done by the applied force in carrying a positive charge Q naught from point B to A without disturbing equilibrium state of the charge. So what is equilibrium state of the charge? Equilibrium means to maintain the state of rest or motion of a charge is called the equilibrium state of the charge. According to work energy theorem, the work done by the force in carrying the test charge for moving from point B to A is equal to the change in potential energy of the charge. It can be written as change in potential energy is equals to work done from point B to A. So change in potential energy is equals to UA minus UB, because at point A, electric potential energy of the charge is greater as compared to the electric potential energy at point B. So UA minus UB is equals to WBA. Here, by dividing Q naught on both sides of the equation, Q naught is divided on this side and Q naught is divided on this side. By separating these terms, UA over Q naught minus UB over Q naught is equals to WBA over Q naught, as V is equals to U over Q naught by considering the electric potential mathematical form. So here we can write UA over Q naught is equals to VA minus UB over Q naught is equals to VB by using this formula, equals to WBA over Q naught, as VA minus VB is equals to del V. So here instead of VA minus VB, I wrote delta V is equals to work done from B to A over Q naught. By replacing Q naught from one side of the equation to other side, Q naught delta V is equals to WBA, as delta U is equals to work done, as I mentioned it in very first step. So here replacing WBA with delta U. At last I shifted Q naught from this side of equation to the other side. So finally I get delta V is equals to VA minus VB is equals to del U over Q naught, and it is our required mathematical form of the electric potential difference. At last, I would like to tell you the unit of electric potential and electric potential difference is volt. So what is volt? 1 volt is 1 volt is the potential difference between 2 points in an electric field if 1 joule of work is done in moving 1 coulomb of charge from one point to other point. Smaller and bigger units of volt are mentioned here. So according to need, we use smaller and bigger units of volt. So smaller unit of volt is 1 millivolt is equals to 10 raised to power minus 3 volt, and bigger units of volt are 1 kilovolt, 1 megavolt and 1 gigavolt.